Spinning quite fast. I thought I would try and issue a quick update, no load connected, as to what's happening here, as I found an unexpected anomaly. This is my H-bridge circuit. I've been asked to post a circuit diagram about. I've made a few modifications and then I've now got it running happily at the maximum voltage and current of this power supply, which is about 520, 530 volts, and input current of also here. I've run out of accurate enough meters, but basically it's about 4 or 5 milliamps, 500 volts, about 2.5 watts. Now, the downside of running a Newman motor is typically you need to find a way to switch it on and off. Commutators and relays have problems, but that's historically what's limited this tech, or this very simple motor. But this H-bridge, I managed to get it working. I got it up to several hundred volts with these 1500 volt transistors before they started exploding. And there was an inherent difficulty with getting that running in a mainstream electronics way, which is the voltage coming from this coil. I may be turning the coil on and off, but the voltage that that magnet is actually creating is travelling through in the other direction at the same time. So it's travelling from the collectors to the base, or collectors to the emitter, depending on which set of transistors we're talking about, and it was damaging them. So the only way to get around this was have a separate power supply for each transistor, and I got that up to, well, about this voltage, about 500 volts with that technique. But I didn't want to run a 9 volt battery on each. So the solution is you need a completely isolated power supply for each transistor. So what I've done here is discovered that is actually possible to get 4 completely or at least 2 completely isolated power supplies from one transformer. The transformer is going straight to a bridge rectifier, charging a capacitor, and that's the power supply that replaces the 9 volt batteries. The difference is I've got a capacitor on each AC line, so that's letting the AC pass, but preventing the DC earths from getting back and joining, because if those DC earths did get back and join, what would ultimately happen is that the emitter of these 2 transistors would join, and that would create a short circuit of 500 odd volts, which would create a dead short across this motor, depending on how it blew, and potentially just, if you short the coil on this motor, the power coil, if you just put a crocodile clip lead between it while it's spinning really fast, and then connect the lead, it'll bang, it'll just stop dead. Yeah, it's got an incredible stopping force and incredible torque. So there you go. I've solved that Newman issue. And just for a giggle, I'll put a bit of a load on this very small motor and see how it goes. So that's going about 15 milliamps or so, 500 volts, and I can stop it if I want to. It's not that powerful, especially with the larger wheel, and it's warm, but it's not that warm. It's not actually that much power. What comes next, though, is of course taking this excellent circuitry to a larger motor. My hand is a bit numb, with a larger wheel and basically the same resistance coil. It's in larger wire, so instead of 40mm magnets, I'm going up to 250mm magnets, and this is about 23 centimeters from top to bottom, so the magnets will go up to about 30 by themselves, and the coil obviously a bit more than that, so that extra leverage angle should make a far greater torque output. And now that the power input is solved, or it seems to be solved anyway, it's going extremely well. The next step, before my magnets arrive and I build the new motor, is to work out just how good this system is, or what its next weakness is. And that's going to be done by pulling this power supply apart tomorrow, and I can quite easily make it put out a bit more power. I've been waiting for that to become necessary, and it finally is. So we'll see just how good it can be. Oh, and of course the reason for actually filming this video is this is the plug for that transformer that's charging these capacitors through this isolation, and of course through a diode. There is a diode between the positives. It should be impossible for the charge to go through the diode that way and charge this capacitor. But it's not. I wanted to see how fast these capacitors go down, one for each, after I undid the plug, because I was going to swap it from the wall into one of these rather crude looking power meters. And it does consume 1.5 watts from that meter, which I don't entirely trust, but I thought it was worth a look. And yeah, as it transpires, that voltage has dropped from 5.66 to fluctuating about exactly there. It's basically dropped almost nothing in 10 minutes. And these capacitors, although quite large, they're not that large. They're 2200 microfarads. 35 volts, 2200 microfarads. So, it's efficient, but not that efficient. Somehow, the charge from this motor is going through the 1000 volt diodes, and rather miraculously, keeping the power source for the motor charged up. Anyway, well, I'll get a bit more power out of my supply, find a weak point, see if we can make something explode for the next video, and figure out that anomaly. Okay. Hope you learned something.